Hello students, this is your science teacher Ben, and I'm sure you are all doing good. So we'll continue with our lesson today right away. So we are in the middle portion of our science second chapter, that is acid, base and salt. So this chapter we have three parts. The first part is we studied acid, base and their properties. So we are done with that, and the middle portion is all about indicators, pH, importance of pH, and the last part of the chapter is salts, which is very important, but students usually ignore that part. So we'll study the indicators, which we have already started in our last class. I've given a little bit of introduction about our indicators. So what does these indicators do? Indicators, they help us to indicate whether the solution or the substance is an acid or base by the change of color or through the smell. Clear? So one such example we have seen, that is litmus in our last class. So that was through change of color. And students, blue to red means that is acid. Clear? So blue litmus changing to red is acid, and red litmus changing to blue is base. Clear? Now the second type of indicator through which we can identify by the change of smell, by the change of color would be turmeric. Turmeric, its the local name is haldi, okay, haldi powder. So through this turmeric as well, we can identify, we can indicate whether a solution or a substance is base or acid. Now, how we'll do this one is, now suppose you make a solution, turmeric powder and a water, clear? And if you put the turmeric solution, in acid, the color which you'll get is just yellow. That's a normal color of turmeric. But if you put a turmeric solution in a base, then the color would turn to reddish brown. It's a colorful reddish brown. So you'll get a reddish brown. That indicates that the solution is basic in nature. Clear? So likewise, we have many other natural sources from where we can indicate whether a substance is acid or base. But for now, we'll just study litmus and turmeric. Clear? Now, the second type of indicator through which we can identify by the change of smell. Clear? So that would be through smell, through changing of smell. This is also known as olfactory indicator. Okay, olfactory indicator. Olfactory indicator. So this actually means that we are able to identify whether the substance is acid or base by their smell. The example here I'll give you onion, since it's a common one where we can all relate. So onion, you all know, onion has a very strong smell because of the sulfur present. So let's take, you can also try this activity at home. So onion, let's make an onion juice, or we can extract the juice, okay? So we can make a solution containing onion, containing onion and water. Clear? So what we will do, we will put either acid or base in this solution. So this is a solution containing onion and water, one, and the same here, another test tube. Let's say this is a test tube. The first test tube, we have the same onion and water. And the second test tube, we have the same onion and a water solution. Now, if I put an acid solution here, let's say HCl, will there be any change? No. The smell, it will be the same smell, but if I put a base, let's say NaOH, if I put a base here in this onion and a water solution, the smell, you won't get the smell anymore. Clear? So that indicates that this solution is a base. Because if you put a base solution in an onion and a water solution, you won't get the smell of onion anymore. So this is also an example of olfactory indicator. Now we have more example. The second example we can give vanilla as well. Vanilla is commonly used in cakes, baking cakes, or ice cream. So this is the same thing where this also we indicate the presence, either it's an acid or base by the change of smell. So these are some example for the indicators, natural source of indicator, because if we see all this, these are all natural indicator. We get it naturally. Litmus is also obtained naturally because the paper, yes, the litmus paper, it is in a process form. But from where we are getting this litmus? We are getting it naturally from a fungus that is lichen. Now the second turmeric, this is also natural obtained. Now the second onion is also natural source. Vanilla, these are all natural source. Now the second type of indicators which we will talk is a synthetic indicator. Now when I say synthetic indicator, that means it's a man-made, okay? Or something that is made from, prepared from laboratory. And these days, you all know, anything is possible, like we can make it, anything can be prepared from lab. So the second type of indicator that we'll talk is a synthetic indicator, okay? Synthetic indicator. Synthetic indicator. So this is a man-made indicator. Now the first one, the common that we use in a practical lab. Now you're in class 10. In class 11, you'll have 30 marks which will consist of practical. So you will see this phenolphthalein indicator, okay? Phenolphthalein. So the name of this indicator is phenolphthalein. It is nothing but it is just a colorless. You will find in a small bottle, it's a colorless, but this is an indicator. This also helps us to identify whether it's an acid or base. How? Now, if this is an acid solution and this is a basic solution, clear? I have two solutions, acid and base. Now, phenolphthalein is a small medicine. We have a dropper, okay, like an eye drop. So we have a dropper. So if I put a small amount of, like small 1-2 drops of phenolphthalein in this acidic solution, it is the same, colorless. There's no any change. But if I put a phenolphthalein drop here in a base solution, then this color, from colorless, it will change to a beautiful pink in color. So that indicates that this solution is basic in nature because it has changed to a pink in color. So in phenolphthalein indicator, that is a man-made indicator, what we'll get to see is in acid, no change, colorless, but in a basic solution, we'll get to see a beautiful pink color. Clear? Now let's see another type of synthetic indicator that will be a methyl orange. Methyl orange. M-E-T-H-Y-Y-L, methyl orange. So this is a second type of synthetic indicator. Now, for acid solution, this is acid solution. Let's take this one is a basic solution, okay? Now, if I put a methyl orange here in acid solution, it will turn to red in color, okay? Red in color. And now, if I put this methyl orange in a base solution, the color you have to remember, it will turn to yellow. So remember, red and yellow. Clear? Acid, red, base, yellow. Clear? So this, from here, we have studied two types of indicator. Phenolphthalein, where the base solution turns to pink in color. Now the second one is methyl orange, where the acid turns to red and the base turns to yellow in color. So we are done with the indicator portion. In exam, what type of question you will ask? You can ask regarding the color, or you can be asked, or they ask difference between natural indicator and synthetic indicator. In natural indicator, you can mention turmeric, litmus, you can mention onion, and in the synthetic indicator, you can mention all this, what we have studied now, phenolphthalein, methyl orange, and so on. Clear? So we are done with this indicator portion. Now, the next topic would be pH. pH scale, and this is very important in chemistry, for chemistry as well, for the whole chemistry, like for further studies. In class 11 also you will study pH more in details, calculations and everything. So pH, where does this pH come from? So here P means, okay, P means it's derived from a German word that is potens. So potens means power, clear? Here the word P here means potens. So potens is a German word. That means in English it's a power. So you have learned a foreign language today as well. Okay, so now H here is hydrogen, okay? H is hydrogen. So together it is power of hydrogen, clear? So pH means power of hydrogen. So from pH, it is a numerical scale. In the last week I said, like I have given an introduction about a pH scale, very short introduction. I said 1 to 14. But even 0 to 14 is also fine, 1 to 14 is also fine, because in some textbook you get 1 to 14, in some text, in your NCERT text is given 0 to 14, so we'll refer 0 to 14. So that means that it's a power of hydrogen. It's a numerical scale to measure the strength of acid and base. Now we know like what is weak acid and what is strong acid. We also know what is strong base and weak base. But there is a strength for all the acid and base. Like which one is like more, they have a ranking, clear? So through this pH scale, this is a universal indicator. Through this pH scale, we will know the strength of any solution, clear? So it's not a geometry that normal scale we're talking about, it's a different scale, okay? So pH scale, you'll have like this. The midpoint is the 7, okay? Midpoint is 7, and 7 is considered as a neutral. That means this is neither acidic, neither it is a base. Now we start from 0 and it goes on till 14. 14. Now, here, see, bases we also call as alkali, okay? The other name of base is alkali. Alkali. Now the difference is all alkali are base, but all base are not alkali, okay? So bases which dissolve in water are known as alkali. So now from 7, from here till 14, it is a base. Now 7 and below, it is an acid. So you have to remember. Now see, pH, okay, now we have pH of tomato. Tomato is a vegetable. pH of tomato is, if this is a tomato and the pH is 4. The pH of tomato normally it is 4. That means 4 is falling under this acid category, right? So that means tomato contains an acid. Clear? And the name of the acid which we get from tomato is an oxalic acid. I'll spell that, I'll write here for you. Oxalic acid. That is an acid which we get from tomato. So this is the pH scale. So now if we go from here, if we come from here, that means the hydrogen ion concentration is increasing. Clear? If we come from here, that means the acidity is increasing. That means lesser the pH, lesser, I'll write everything in bold letter. Lesser the pH, more strong acid. Clear? So see, king of acid, we call it as like 1, has a pH 1, that is sulfuric acid. Why it is? Because it's more strong. The acid, since the pH is 1, it is considered to be strong because the pH is lesser. pH is lesser. Now, if we have something, okay, now NaOH, why it is considered to be a strong base? Because the pH is more than 13. It's somewhere, pH is around 13. So it lies towards here. Clear? So whatever, if the pH is found somewhere between this, that means we consider it as weak acid or a weak base. So we'll study the importance of pH, why this pH is very important. See, human beings, plants, animals are sensitive to pH as well. Why? Because our normal working body requires a certain pH to function. We need a pH around 7.0 to 7.8. This is the pH that we need. For a normal healthy body, the pH should be within 7.0 to 7.8. Clear? Now, you have all heard about acid rain. Acid rain, what happens is that the pH of rainwater goes below 5.6. So 5.6 means, that means the water is already acid because 7 and below is acid. So that means the rainwater consists of acids now. So what will happen? Now those water will flow into rivers, oceans, and the aquatic life would be in danger. Clear? So that from here we can conclude that plants, animals are all sensitive to pH. Clear? Now the second type is pH and soil, okay? Now for a healthy growth of plant, the pH should be neutral. It should be somewhere in this 7. So how will you know that the pH, the soil is either acid or base? We have a certain steps to measure that. Now in certain place, even in India, they do this a lot because a large part where the cultivation are done in a large number, what they do is first before cultivation, they first check the pH of soil. If it is acid, they neutralize it by applying a base. If the soil is base, they neutralize it by applying an acid. So now see, what you can do is these days going out is restricted and it's good for us. So many people are starting a cultivation, small plantation just near the backyard. So the pH of the soil should be within the 7. And how you will measure that? How you will test the pH? You can just take a small amount of soil, put it in a glass, and then you put a water, just shake it, and then you filter it, and then take the water out of it. And then, okay, but the litmus paper is a problem. If you have a blue, you'll get blue litmus and red litmus. So you need these two paper. So if you put that blue litmus paper in that glass tube, and if the blue changes to red in color, that means that soil is acidic, since the color has changed from red. But the other one, if you put the red litmus in the solution, that soil solution and water, and if the color has been changed to blue color, from red to blue, then the soil is basic in nature. So in this way, we can identify whether the soil is neutral or not, whether the soil is suitable for a cultivation or not. Clear? Now, let's talk about digestion, the third part. Even inside our body, do you know that we have an acid? We have, our stomach produce acid. And what acid is that? Students? So inside our stomach, we also have an acid that is HCl, hydrochloric acid. Our stomach produces hydrochloric acid. And now what do you know what will happen if this there is a large amount of like hydrochloric acid is produced inside the stomach? That's when you get a irritation, or that's when you get an acidity. That's when you get acidity, irritation, or that's when you get a stomach ache. Clear? In that case, why? Because the acidity is increasing. HCl, there's large amount of HCl producing inside the stomach. So how do we neutralize that one? Since more acid, we need a base to neutralize the acidity. We need a base to control this HCl. So you often, I'm sure you all have heard about Eno, which you get in the chemist or you get in a shop. So you buy this one. I'm sure you are familiar with this Eno. So this Eno, the other thing we can use is antacid, okay? Antacid. Antacid is also used to neutralize the excess acidity inside the stomach. Clear? Now, the other thing we also use mild base are milk of magnesia, okay? Milk of magnesia. Milk of magnesia. So this, see, Eno and antacid are the same thing, clear? Milk of magnesia are what we are advised to take to neutralize the acidity, the excess acidity inside the stomach. Clear? Okay, now let's discuss about toothache, okay? Tooth decay. So whatever I'm discussing is the importance of pH in our everyday life. We're not familiar, we don't talk about pH every day, but how pH is very important in our daily life. So let's talk about tooth decay. Do you know when our mouth, inside our mouth, if the pH is low, pH inside our mouth, pH is lower than 5.5, then tooth decay, toothache, and everything will start. Because what happens is that there is a bacteria present inside our mouth. Now, might be gross, but it is reality. Like after you consume food, there will be some remaining like food particles inside your teeth. So degradation of those happens. Degradation of sugars, degradation of food particles happen. So degradation of sugar and food particles lead to a tooth decay. So that means acidity is increasing. So we need to neutralize the excess acid. So prevention is we can always clean the mouth right after we eat food, clear? Brush twice, at least twice regularly. And the Colgate that we use, the toothpaste, the Colgate that we use contains a base. So see, acidity, there's an acidity inside the mouth. And to neutralize this, we need a Colgate. And Colgate or any toothpaste contains a base. That's how they neutralize each other. So from here, I'm sure you are clear with all the pH and their importance in our everyday life. So now from here, one question, if I ask you, I'm sure you will be able to say in your own word, that is, what is a neutralization? Or neutralized reaction. That is, when acid and base together they react, they are giving us a neutral salt and water. And I'll show you here. Acid plus base is always a neutral. So we'll get a neutral salt and water. So this is a neutralization reaction, okay, students? So we are done with the importance of pH, and now we'll go to our last part of this, last part of the chapter, that is salts. Salts, and this is very important. Most of the students, they ignore this last portion, but salt is very important. From the time of freedom struggle, you have heard Dundee March, that was all about the salt. Till today, every day, we need salt, right? So let's study this salt in detail. So first, let's talk about the common salt. First, let's talk about the common salt. And the chemical name for this common salt is, the chemical name for this common salt, chemical name for this common salt is NaCl. Clear? And this salt is considered to be neutral. Neutral salt. That means, do we also have an acidic salt? Do we also have a basic salt? Yes, we have. Now we have neutral salt, but we also have an acid salt, and we also have a basic salt. So, how do we get an acidic salt? Have you ever heard about an acidic salt? Okay, acidic salt. Acidic salt. When we react, okay, this is very simple here, students. When we react, and it's there in your textbook, you can refer as well. Acidic salt is when we react strong acid. Strong acid. When we react a strong acid with a weak base. With a weak base. What do we get? We get a acidic salt, since the acid is stronger here. So we get acidic salt and water. Why water? Because acid and salt reacting always will get water. So any one example of acidic salt? Okay, that means strong acid, let's give HCl. Weak base, let's give ammonium hydroxide. NH4OH is the ammonium hydroxide, okay? So we'll get water, acid and base will get water for sure. So one H, other H, one O is gone. So that means H2O is here, okay? So now what is left? We have ammonium, NH4Cl. So this is an acidic salt. Clear? So this is the salt, this is the water, and this can be an example for acidic salt if you are asked in exam. Okay? Now next is a basic salt. Basic salt. For basic salt, we need a strong base. Strong base and weak acid. Weak acid. Strong base and weak acid react together to give a basic salt. Basic salt and water. See, when we react a strong acid with a weak base, we're getting a acidic salt. But when we are reacting a strong base with a weak acid, we will get salt for sure, because acid and base we are reacting, so we will get salt. But what kind of salt? Since we're reacting it with a strong base, we'll get a basic salt. Now for this, let's give an example. Strong base, let's give sodium hydroxide. NaOH is a sodium hydroxide. Weak acid. Weak acid are those which are hard to break completely. I have given example, that is acetic acids, which we get from the vinegar. So now what will happen? So this is a strong base and this is a weak acid. So we know, I have already repeated again, that acid and base, we will always get water. Clear? That means what is left? So we'll get, see, one H, another H, so two H is gone, one O is gone. So what is left here? CH3COONA. So the other word for CH3COONA is sodium acetate, okay? Sodium acetate. Sodium acetate. So students, from here we are clear with different type of salts. Neutral salt, acidic salt, and basic salt. So I'm sure you have noted down all the chemical equations involving this acidic, basic, and neutral salt. Neutral will get when strong and strong battles together. Clear? Strong acid, strong base, neutral salt. Strong acid, weak base will get acidic salt. Now, strong base and weak acid, we're getting a basic salt. So this is a different type of salt. Clear? So you can make a note regarding this different type of salts. And in the next class, we'll start with the important properties of salt, which is very important because those are usually asked like in the exams, and it will help you even in your further studies as well. So we have, I'll give you the names, and I will suggest every one of you to note down the name so that you'll get familiar with the name, and in the next class we'll start right straight with the topic. Clear? So the name, the important properties of salt would be, the first one would be, let's give you a common name, okay? Common name. Let's give you a common name. So the first one would be caustic soda. Caustic soda. Clear? Caustic soda. Now the second one would be bleaching powder. Bleaching powder. The third one would be washing soda. The fourth one would be baking soda. And the last one would be plaster of Paris. Plaster of Paris. So I will request every one of you to note down these like important properties of salts just to save time and also to get familiar with all these names, because in the next class we will study their chemical names, the property, the uses, and the preparations, which are very important. Clear? Okay, so to continue with your regular studies, and I'll see you in the next class. Clear? Thank you so much, students.